Very good morning to one and all. In this class, let us discuss about nodal analysis. For this given circuit, uh, the current in the 10 ohm resistor, we are going to calculate with the help of the nodal analysis. First of all, the nodal analysis is one among the methods to calculate the branch current or a branch voltage or power dissipation in any of the resistor. So, in the previous class, I have explained what is the difference between node and a junction. So here, more than two branches meeting at a point, you can call it as a node. In other words, a node is a place where the current is divided or the current are confluence there. So look at this. This is the reference node, of course. Here the 5 ohm, 2 ohm and 10 ohm and this 5 ampere source are connected at this point. This you can call it as a node. This point you can call it as a node. Of course, this is also a node, but it is a reference node. So when you're writing the equation, Kirchhoff's current law, first point is we have to assume the current directions. Then for that current directions, we have to write the Kirchhoff's current law equations. Compared with the nodal analysis, compared with the mesh analysis, this nodal analysis is easier because the number of equation is based on the number of nodes. Exclude this reference node. So only one node, one equation, right? So now let us see, on solving this, we will be getting the value of V1, that is at this node voltage with respect to the ground is 8.75. The current flowing through is 10 ohm resistance is 0.875. How? As I told you, this V1 is a potential difference between this point to this reference. It is called as V1. This is a node 1, only one node. This is not a node. Node is a place where the current entry and leaving both will be different. So this you cannot say it as this point, you cannot say it as a node because whatever the current comes here, the same amount of current goes here, right? So you cannot say this point as a node, but this is a node. Here the current is changes, right? Fine. Now how do you write the nodal equation? The nodal equation V1, this potential minus 10 by 5. It means that this V1, this is the entry current. As far as this node is concerned, this is the entry current. The rest of the branches having leaving currents, like that we will assume it. So this is the entry current. The entry current is equal to this one 5. Next one is V1 by 10. So this one V1, same voltage, V1 divided by 10. In fact, this one is V1 minus 0 divided by the resistance 10. Again, I mean 5 ampere current is equal to this current plus this current plus this current, these three currents. So this already I explained, V1 minus 0 by 10. Next one is V1 by 2. Look at this one again, V1 minus 0 by 2. Yeah, this current also over. This also over. This is the entry current, 5 ampere, right? So this is over. Next one is this one. This current, as the direction is assumed like this, so this should be the higher potential. Always current flows from higher potential to lower potential. So V1 minus 10 ampere divided by the resistance 5, right? Understand? So now V1 minus 10 divided by 5 this. So this is the equation. Now look at this circuit in which how many nodes are there? In the given circuit, you can find this is a node 1, node 2, node 3. Of course, this is a node, but usually the reference node is not taken into account for writing the Kirchhoff's current law equations. So for the node 1, you have to write the equation entry current is equal to leaving current. You can assume your own directions. You can assume in this way or you can assume in this way. Any direction, you can assume this way or you can assume this way. For this node, you can assume this way or this way. Any direction you can assume, but once you Decide it, don't change it, and write the equations, right? Fix the directions first. Name the current I1, I2, I3, and then start writing the Kirchhoff's current law equations. Totally 3 nodes, so 3 equations you have to write it. So these two are the entry current towards this node 1 and 3 respectively, right? So if you write the equation, for the first node, this is the equation. For the second node, this is the equation. For the third node, is the equation. Very simple. For the first node, this is the entry current. This entry current is equal to leaving current. The leaving current is V1 minus 0 divided by 1 ohm. V1 minus V2 by 2. It means that the V1 potential is higher than this V2. Based on the direction, here it is written like this. Similarly, V3 is lesser than this V1. That is the reason why V1 minus V3 by 4. Current always flows from higher potential to lower potential. In the same way, you have to write the 3 equations. All the 3 equations. 1, 2, 3.